Okay, so recall the theorem. Recall the following theorem from last time. We said that the volume of the parallelopipe determined by three vectors A, B, and C is the scalar triple product. Okay, so So the volume V is given as the absolute value of A dot B cross C, like so. And the only reason we take the absolute value is because the dot product can be either positive or negative. So and the volume, of course, require the volume to be positive. So here's the example that I chose not to do last time. So show that the following vector, the vectors, and we have the following vectors. The vector A is 1, 4, and negative 7. Vector B is 2, negative 1, and 4. And vector C is 0, negative 9, and 18. We want to show that these vectors are coplanar. Now, what the heck is coplanar? Well, they lie, all three vectors lie on the same plane. And as such, we cannot create a parallelopipe because they're on the same plane. So we don't have height to speak of, and the volume will be 0. So this leads us to a property the following property. If V equals the absolute value of A dot the quantity, the vector B cross C, if this is 0, then the vectors A, B, and C are coplanar. So all we need to do to answer or to show that the three given vectors are coplanar is to perform or attempt to calculate the volume, and if the volume amount to 0, then we are good. So to solve it first, let's see, can I do it in one shot? I'm sorry? Right, thank you. But I'm thinking now, can I do it in one shot? Yeah, we can do it in one shot. Let's see, we'll go A, which is 1, 4, negative 7, and we do dot. And here we have the cross product. Remember how we do cross product? We have ijk, like so, and then B is 2, negative 1, and 4, and C is 0, negative 9, and 18. Like so. So actually it's foolish to use mixed notation here. So let me change the notation of A from component notation ijk to ijk notation. So vector A will be I plus 4j minus 7k. Okay, like so. And now we keep the vector A and we'll perform this one. So in the I direction, what do we have? We have negative 1 times 18, negative 18 minus negative 36, so it would be positive 18. So we have 18I, and in the J, we have a negative in front of the J, right? So we have 2 times 18 minus 0, so 36, but negative in front, so negative 36J. And in the K, we have negative 18 minus 0, so negative 18K. And now, all we need to do is perform the dot product here, so it will be 18 4 times 36, I believe it's 144, so minus 144. And what the heck is 7 times 18? Well, it will be 1756, so 126, so plus 126, indeed it's equals 0. So the conclusion is A, B, and C are coplanar.